Hey, welcome back to RamZland. Today I want to show you how coupled oscillations with my Wilberforce pendulum can transfer from longitudinal oscillations to rotational oscillations. Check this out. In this investigation, I'm using straight pins, 2 tennis balls, scissors, some string, a tall stand, a spring, and a special Wilberforce pendulum. To demonstrate coupled oscillations with a tennis ball, I'm going to take a straight pin and carefully poke it in one side of the tennis ball, and I'm going to leave about 1 centimeter sticking out to tie the string to. Poke another needle into the second tennis ball so they look the same. Next, using your scissors, cut 2 equal lengths of string to tie it to each tennis ball. To balance your oscillations, you want to have the mass of each bob the same, so we're using the same needle, same size tennis ball, but you also want the length of the string to be equal. So make sure you trim the string after you tie it to make them equal again. The next step is to align 2 chairs back to back. I'm going to take some string and I'm going to tie it to each chair. I'm going to make the string taut by just simply sliding the chairs apart from each other. So here's one end, and then I'm going to tie the other end to the second chair. Again, to make the string tight, simply slide the chairs apart from each other. Next, you're going to tie 1 tennis ball close to the center of the string, and you'll tie the second tennis ball next to it. Again, you want the length of each tennis ball to be the same. There's one. After you've tied the second tennis ball, if you notice that one bob is slightly longer than the second bob, you can simply loop it around once, like so. Thereby making them the same length. Because you want to calibrate both bobs to be equal so they can transfer energy from one pendulum to the other. I like coupled oscillators because they illustrate the law of conservation of energy. When I pull back one oscillator, its potential energy becomes kinetic energy when I release it. But that energy transfers to the second oscillator, and you'll start to see that it'll move in tandem with the first oscillator until the first oscillator starts to slow down and it'll come to a stop as it transfers its energy to the second oscillator. And after a few moments, that second oscillator, it will start to slow down and it will come to a stop when it transfers its energy to the first oscillator. And now it's come to a complete stop. And now the first oscillator absorbs that energy and it starts to move back and forth. Pretty soon this will happen again as the first oscillator comes to a complete stop, and it will transfer that energy to the second oscillator. Another amazing coupled oscillator is the Wilberforce pendulum. This was made by Lionel Wilberforce in 1897, and what he found is if you attached a spring to a bob that had weights that could be calibrated on each side of the bob, that it would transfer its longitudinal oscillation up and down to a rotational oscillation where the bob would spin back and forth. Now, if these counterweights on each side are equal, then the calibration allows the longitudinal energy to be transferred only to rotational energy. In other words, it'll stop going up and down and the bob will just spin. And then after a while, the bob will stop spinning and it'll only oscillate longitudinally up and down. So I'm going to connect the other side of the spring to a long stand and we're going to test it. So as you can see, the spring is rather long. And I'm going to scoot the stand off the edge of the table so when it goes back and forth, it doesn't collide with the table. But I'm also going to kind of zoom in on the bottom of the bob so you can see it change from longitudinal energy to rotational energy. Here you can definitely see that rotational oscillation of the bob, and then it'll stop. And it'll transfer all of its energy to the longitudinal oscillation of the spring, up and down. Then it'll start to spin again, then it'll stop. And now it's just going up and down until it starts to spin again. Wait a minute for the rotational oscillation to stop. There, it stopped right there. And now it starts again. And this transfer of energy from longitudinal oscillations up and down to rotational oscillations in a circle will continue. So what Wilberforce discovered in this coupled oscillator is that the spring, as it went up and down, it would slowly and slightly unwind itself, causing the oscillator to turn in one direction when it contracted, and when it stretched out to spin in the opposite direction. Of course, the first person to investigate pendulums was Galileo Galilei, and in the 1600s he wrote this letter stating, "This requires once and for all the 3 or 4 patient and curious friends, having noted a fixed star that stands against some fixed marker, taking a pendulum of any length, shall go counting its vibrations during the whole time of the return of the fixed star to the original point, and this will be the number of vibrations in 24 hours. And so he waited until darkness fell, and as stars appeared, when a star was over a fixed point, he released his pendulum, and he and his friends counted the oscillations. Now, I imagine during the day and night, they probably gave that little pendulum a nudge or two to keep it going back and forth, counting the oscillations during a 24 period and waiting until night fell again and for that star to reach that same fixed point to determine how many oscillations it would take for that pendulum during a 24-hour cycle." I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.